All right, so welcome to this video. Today we'll be looking at how to decompose a single fraction into its partial fractions. Okay, so for example, okay, if I have 1 over 2 plus 4, or let me say 5, not 5, but let me say 6 over 2, okay? Let's say I have those two fractions there, and then I want to add them, okay? So I'll say the common denominator there is 2. 2 into 2 is 1 multiplied by 1, I get 1 plus 2 into 2, it's 1 multiplied by 6, I get 6. So it means my final answer here will simply be 7 over what? Over 2. So you've seen that from these two fractions here, I've gotten one fraction. Okay, so now when we're handling this topic, partial fractions, we'll be doing the opposite. We'll have one fraction, and then from the one fraction, we're going to be getting two or more fractions. Okay, so in partial fractions, we'll be trying to decompose this, okay, into its what? Into its partial fractions. That's what we'll be doing. So you can see all these fractions form here. Okay, we just want to try and find out where did these fractions come from. Okay, that's what we'll be doing. So in simpler terms. Okay, so now when you are decomposing partial fractions, okay, or when you're decomposing into partial fractions, there are rules that you should always follow. Okay, so since these are fractions, then we have the numerator and the denominator, right? Okay, so the first rule that you have to take note of is this one, okay? You can only decompose an expression into its partial fractions, okay, if the highest power on x in the numerator, okay, is less than the highest power of x in the denominator. That's the only time you can decompose an expression into partial fraction. So let's say, for example, I have x plus, let's say x squared plus 2x and then plus 5. And then I'm dividing this, okay, by, let's say, x to the power 3 and then plus 2x plus 2x squared plus x and then plus 1. So now, take a look at the highest power of x in the numerator and the denominator. So in the numerator, the highest power is 2. In the denominator, the highest power of x is what? Is 3. So when the highest power, okay, on x in the numerator is less than the highest power on x in the denominator, that's the only time you can decompose something into its partial fractions, okay? When it happens that the highest power, okay, in the numerator is equal or greater than that of the denominator, then we can't apply the decomposition directly. We need, first of all, to divide that expression by long division, and then now we're going to proceed with what we are going to get. Okay, so let's say, for example, if I have something like x to the power 3 minus 4x plus 5 divided by x minus 1 and then x minus 2. So the highest power in the numerator, I can see it's 3. What is the highest power of x in the denominator? So I'll have to expand here to know it. So it will be x multiplied by x, so that will be x squared. So we see that the highest power in the numerator is actually greater than the highest power in the what? In the denominator. So here, we can't proceed with the decomposition. First of all, I have to divide this, the expression here, using long division, okay? And then what I'm going to get is what I'm going to decompose. Okay, so specifically, this is what will happen. So for example, if I have f of x here, okay, and then I'm dividing by g of x. So let's say f of x here, okay, has a degree, or it has the highest, it has the highest power on x, which is greater than the highest power of x in the numerator. So let's say the highest power in the denominator is 2, and then the highest power in the numerator is 3. So here we can't apply directly the decomposition. First of all, we divide this by long division. So once we divide this, of course, we're going to get the quotient, which is the answer, and then plus the remainder. Okay, so now this remainder, you're going to divide it by the function which was down there. Okay, so now the part that you're going to decompose is this part. Okay, so we're going to decompose this part and then add it to the quotient of what you got when you divided those two functions. That will be your what? Your final answer. Okay, anyway, if your function passes through the first stage without any problems, then you should shift your focus to the what? To the denominator. So meaning that the numerator has a power which is less than the what? the power of the denominator. Then your focus should shift to the what? To the denominator. Okay, so when it comes to denominators, we have types of denominators. Okay, we have types of denominators. We have linear denominators. Okay, we have repeating denominators. We have unfactorizable denominators, and then we have the combination of the two. So what do we mean by linear denominators? So for example, if I have a function on top there divided by x, okay, let's say plus a, and then x minus c. Okay, so to decompose this, we're just going to say this is equals to, okay, a or any letter of your choice divided by the first factor, and then plus b divided by x minus c. Okay, and then we go on with the decomposition. All right, so this is when you have linear factors like these ones here. What if you have repeating factors? So repeating factors simply means one linear factor is repeating more than once. Okay, so it might be x plus a to the power 3, and then x minus c to the power 2. So how do we handle these repeating factors? Okay, so we're going to say a divided by, so I'll start with this one. So the first factor that I'm going to write, I'm going to raise it to the power 1. So it will be x plus a to the power 1. So I'm going to keep on increasing the powers until I reach the highest power that I have. So the next will just be b divided by x plus a to the power 2, and then plus c divided by x plus a to the power 3. So until you reach the highest power that you have there, that's when you stop. So the powers should be increasing like that. So this one was just for the first factor. Even for the second factor, we do the same. So that would be plus d divided by x minus c to the power 1, and then plus e divided by x minus c, and then to the power what? 2. So until you reach the highest power that you have on that factor. So you keep on increasing by 1. So this is how we're going to be handling repeating what? Factors. Okay, so there's also a time when you have what we call as unfactorizable factors. So unfactorizable factors, these are factors that you cannot factorize. So for example, x squared plus a. So no matter what you do to this, you can't factorize it, okay? Or if I have x squared plus b, okay? No matter what I do to this, I can't factorize it. So how are we going to handle such unfactorizable factors? We're going to say this unfactorizable factor is always over a linear equation. So that would be a x plus b for the first unfactorizable factor. Okay, and then I'll say plus, even this one is unfactorizable, so it has to be under a linear equation. So that would be cx plus d divided by what? X squared plus b. So this is how we are going to be handling a what? An unfactorizable what? An unfactorizable factor. Okay, and then there are questions where there's just a combination of these three. So there will be a linear factor there, a repeating, and then unfactorizable one. So let's give an example. Okay, so for example, if I have f of x divided by x plus a, this is linear, and then x minus b squared, this is repeating, and then x squared plus c. This is unfactorizable. So each of these we stated the rules that we use, right? So for the linear, so that's going to be constant divided by that factor, and then plus. For the repeating, it will be a constant divided by that factor to the power 1, and then plus another constant divided by that same factor, but now the power has to increase to what? To 2. And then for this one, which is unfactorizable, we're going to say we need a linear equation, okay, divided by the unfactorizable factor like this. Then once we have this, we can go on with our decomposition. Okay, so it's very important to know the type of denominators that you're dealing with in your question. All right, so what next now after writing this fraction in this form? So this is what we call as a partial expansion. So from there now, the next step I'll be showing them as I solve this. So the first one, you can see it's 7x minus 5 divided by x minus 4, and then x plus 2. Okay, so this is what we have. So we can see that if I combine these factors, the highest power of x there will be x squared. The highest power here is 1. So the highest power in the numerator is less than the highest power in the denominator. So I'm good to go. Okay, I can decompose that guy. So now you check the type of denominators. These are just linear denominators. So this will just be equals to A divided by the first linear factor plus B divided by the second linear factor. Okay, and then once you have that, what do you do? Okay, so once you make your partial expansion, you are going to multiply throughout by the denominator that you have on the left. So the denominator on the left is simply x minus 4 and then x plus 2. So this whole thing here multiplied by this whole thing, it will cancel out with this denominator. So I just remain with 7x minus 5 is equals to, if I multiply this, multiplied by a divided by x minus 4, the x minus 4 will cancel out with the x minus 4. So I remain with a multiplying x plus 2. Okay, and then plus, if I multiply this guy with this, okay, the x plus 2 is going to cancel out. So I remain with b multiplied by x minus 4. So in case someone is not seeing what is happening, it's this one. So if I multiply this with this one, what I'm simply saying is x minus 4 and then x plus 2 multiplied by a over x minus 4. So you see that the x minus 4 cancels with the x minus 4. So I just remain with a multiplied by this. This is what I wrote here. And it's the same thing that is going to happen there. Okay, so now once you have this, okay, here you can use two methods now. You can use elimination or you can use the one where we expand. Okay, so elimination or elimination only works if the factors that you have there are different. Okay, like the way they are, then elimination is the best method to use. Okay, but if the factors are not different, then we'll be using what? Expansion. So here I'm going to say, let's eliminate this a, and then we just remain with the x. Okay, so how can I eliminate this a? I'm going to say, let this guy be equals to 0. Okay, so if this guy is 0, then a multiplied by 0, the a will disappear. So this x plus 2 is equals to 0 simply also mean that x is equals to what? Minus 2. So simply meaning that wherever there's x here, I'm going to put minus 2. So that will be 7 minus 2 minus 5 is equals to a. Where there's x there, minus 2 plus b, and then minus 2 minus 4. So here, I'm going to have 0. So a multiplied by 0, that is just 0. Then this one is minus 14 here. Okay, minus 5 is equals to, here we're going to get a 0. And then there, this is minus 6. So minus 6b. So here I'm having, I'll have minus 19 is equals to minus 6b. And then I divide both sides by the minus 6b. The minus 6, sorry. So it means I'll just have b is equals to minus, in fact, the minus cancels out. So I'll just have b is equals to 19 over what? 6. So we found the value of what? The value of b. So what about the value of a? So if I want to find the value of a, then I have to eliminate the b. So to eliminate the b, I'll set x minus 4 to be equals to 0, which simply means x is equals to 4. So this will be 7 multiplied by 4 minus 5 is equals to a. And then this x is simply 4 plus 2 plus b. And then this x again is 4 minus 4. So this 7 multiplied by 4, okay, it's going to give me 28. 28 minus 5 is going to give me a 23. So I have a 23 here is equals to, this will be 6 here multiplied by a, 6a. So divide by 6, my a is simply 23 over what? 6. So a is equals to 23 over 6. So we are done. Okay, we found the values of a and b. So it means we've decomposed this fraction here into its what? Into its partial fractions. Okay, so I'm just going to erase now where there was a there and where there's b and put the values that we found. So for a, that was 23 over 6. For b, we found it was 19 over what? 6. Okay, but you don't leave your answer like that. You want to remove this fraction from the what? From the numerator. So how can you do that? I'm going to multiply this guy by 6. So once you multiply this guy by 6, okay, you also multiply the denominator by 6. So you multiply by whatever value that you have, which is dividing this fraction here. If it was just one number, then we would have just left it like that. Okay. And then even here, since the denominator is 6, I'll multiply the numerator by 6 and the denominator by 6. So what I get is that here, if I multiply 23 over 6 multiplied by 6, 6 and 6 goes. So I mean the 23 divided by 6 and then x minus 4. Then plus here, okay, I'm just remaining with the 19. And then this 6 multiply this will be 6x plus 2. Okay, so these here are the two fractions, this one and this one, where this guy came from. Okay, so we have decomposed that expression into its partial fractions. All right, let's look at B. So we're doing the same thing. So for B, we have, okay, we have 4x plus 11 divided by x plus 3, and then 2x minus 1. Okay, again, we have linear factors. So this will just be a over the first factor plus b over the second factor. Okay, and then from there, we're going to multiply this whole expression by the denominator that we have on the left. So that will be x plus 3, and then 2x minus 1. All right, so if I multiply this with this, I just get 4x plus 11 is equals to, okay? If I multiply this by this, the x plus 3 is going to cancel. So I remain with x, I remain with a multiplied by 2x minus 1. Plus, if I multiply this factor with this, the 2x minus 1 is going to cancel. So I remain with what? Okay, I remain with b multiplied by x plus 3. Okay, so to find the value of a, I need to eliminate the b. So I can only eliminate this b if I say x plus 3 is equals to 0. So that will mean that x is equals to minus 3. So 4 minus 3 plus 11 is equals to a 2 minus 3 minus 1 plus b minus 3 plus 3. So you see that this guy here becomes 0. So what I remain with is 4 multiplied by minus 3 minus 12 plus 11 is equals to, here I have a, and then inside 2 multiplied by minus 3, that will be minus 6 minus 1. Okay, so meaning that here I'm going to get minus 1 is equals to minus 7a. Divide both sides by minus 7, I get my a to be equals to 1 over what? 7. All right, found my values of, I found the value of a. Let's find the value of b. So to find the value of b, what are we going to do? Okay, to find the value of b, we eliminate a. So how can we eliminate a? We're going to set this to be equals to 0. So 2x minus 1 is equals to 0, simply meaning that 2x is equals to 1, which means that x is equals to 1 over 2. All right, so this will be 4, and then 1 over 2 plus 11 is equals to a, and then 2, 1 over 2 minus 1, and then plus b, 1 over 2 plus 3. Okay, so this will be 2 plus 11 is equals to, here this will be 2 multiplied by half, I get 1. 1 minus 1, 0. So a multiplied by 0, this will just be 0 plus b, and then here, this will be half plus 3. So half plus 3, common denominator 2, 2 into there 1, multiplied by that, 1 plus 2 into this, 2. 2 multiplied by 3, 6. So I get 7 over 2. Okay, so this will be 2 plus 11, I get 13 is equals to 7 over 2b. All right, and then to cancel out or to find the value of b, I'm just going to multiply throughout by 2 over 7. So if I multiply this by 2 over 7, I'm going to get 23 over 7 is equals to, if I multiply this by 2 over 7, okay, the 2 over 7 is going to cancel out with the 7 over 2. So I just remain with b. So my b is just 23 over 7. All right, so I found the value of a, the value of b. I can just simply now go and replace them into that expression. So I can erase this a, erase this b. So it means I'm going to have, okay, so for a, x plus a, x plus 3 there, it is over a. A is 1 over 7. Then for this guy, it's over 23 over 7. So you don't leave the fractions there. So I multiply this by 7. I multiply again the denominator by 7. Multiply this by 7. I multiply again the denominator by 7. So meaning that I'm just going to have, okay, my final answer will be 1 divided by 7, x plus 3. And then plus, on the other side, to be 23 over 7, 2x minus 1. Okay, so that will mean that we've decomposed our partial fraction into its what? Into its fractions. Yeah, so I think this was supposed to be 26, if I'm not mistaken. Okay, why is it 23? Why is it 23? Because I remember I multiplied like 13. Was it 13? Yes, 2 multiplied by 13. So that was supposed to be 26 over 7. So correct it, okay? But you've seen how we solved it, right? Okay, so the final answer was, let me just write the final answer here. So that is 26 over 7. So the final answer was 1 over 7 x plus 3, and then plus 26 over 7 2x minus 1. All right, so that is how we deal with that, okay? So those are all linear factors. Okay, so now when I look at part C, when I also look at part D, okay, so not really. Okay, so part D is just fine, but part C is not fine. Okay, so this is what I mean. So part C is 3x squared minus x plus 8. Okay, that is what I have there. And then this divided by, I have x minus 1 and then x plus 4. So if I take a look at the highest power in the numerator is 2, and the highest power in the denominator is also going to be 2. Okay, so we can't proceed to decompose this into its partial fractions. No, first of all, we have to carry out what? We have to carry out long division. So let's expand what we have there. So x multiplied by x squared, x multiplied by 4, I get plus 4x, minus 1 multiplied by x, I get minus x, and then minus 1 multiplied by 4, I get minus 4. So this will just be x squared plus 3x minus 4. Okay, so I have to divide this guy with this guy. So it will be long division, so I write something like this. So it will be x squared plus 3x minus 4, and then 3x squared minus x plus 8. So this is what I have here. Okay, so I do long division. So it will be x squared into x squared. Okay, x squared into 3x squared, I'm going to get 3. Then 3 multiplied by this, I'll get 3x squared. 3 multiplied by this, I get plus 9x. 3 multiplied by this, I get minus 12. Okay, so that is what I get. And then I'm going to say here, I subtract. So 3x squared minus 3x squared, I get 0. Minus x minus, minus 9x, I get minus 10x. 8 minus minus 8. So that is 8 minus minus 12. So that will just be 8 plus 12, which will just be what? 20. Okay, so this will be plus 20. And then I try to divide x squared into 10x. It can't. So it means this here is my remainder. Okay, so meaning that when I divide these two expressions, okay, what I get is, when I divide these two expressions, what I get is 3 plus the remainder is this. Okay, the remainder is this, which is okay, so the remainder is minus 10x, okay, plus 20 divided by the initial guy that we had there, which is x minus 1 and then x plus 4. So that's what we get when we do long division there. Okay, that's what we get when we do long division there. All right, so let's just check if we did the correct multiplication here. So 3 multiplied by this, I get this. Okay, 3 multiplied by this plus 9x. Okay, and then 3 multiplied by this minus 12x. 3x minus 3x, 0x minus x minus 9x, I get minus 10x. 8 minus minus 12, I get 8 plus 12, which is just 20. Okay, this is the 20 that I wrote. Okay, so I'm good to go. So now I'm going to decompose that part which has the remainder divided by those factors. So this part here is what I'm going to decompose now. So it will be minus 10x plus 20 divided by x minus 1, okay, and then x plus 4. Okay, so this is what I get. So this will now be equals to a over the first factor, then b over the second factor. All right, so this here and that there. So I'm just going to multiply now throughout by this denominator here. So that will be x minus 1 and then x plus 4. Okay, so when I multiply throughout, I'll just remain with minus 10x plus 20 is equals to, when I multiply this with this, okay, the x minus 1 cancels out, so I remain with the x, I remain with the a multiplied by x plus 4, okay, and then plus b. When I multiply this with this, the x plus 4 cancels out, I remain with x minus 1. So now I want to find the values of a and b. So I just have to eliminate one of these. So it will be x plus 4 is equals to 0, meaning x is equals to minus 4. So wherever there's x, I put minus 4 plus 20 is equals to a minus 4 plus 4 plus b minus 4 minus 4, minus 1. So this here will be minus 40, actually positive 40, right? So positive 40 plus 20 is equals to, this will be 0, and then this will be minus 5b. I divide by minus 5, and then here I'm just going to get what? Okay, so before I divide, let's combine. 40 plus 20, that is 60, is equals to minus 5b. Okay, so that's the same as minus 5b is equals to 60, divided by minus 5, divided by minus 5, b will be equals to 60 divided by minus 5. So that would be minus 12. Okay, so my b is simply equals to minus 12. All right, what about, what about the a? So to find the a, we're going to eliminate the b. So meaning x minus 1 should be equals to 0. So x is equals to 1. So this here will be minus 10. 1 plus 20 is equals to a, 1 plus 4 plus b, 1 minus 1. So this will just become 0. So I just have minus 10 plus 20, that will be 10, is equals to 5a. So I divide by 5, divide by 5. This will just be a is equals to 2. Okay, so a is simply equals to 2. Okay, so simply meaning that we are done with this guy. So I'm going to say my final answer should be represented in this form. So it will be 3x squared minus x plus 8 divided by, okay, so divided by x minus 1, and then x plus 4 is equals to 3 plus, and then when you decompose this, we'll have that a divided by x minus 1, and then plus, okay, b, which is a minus, so I just write minus 12 divided by x plus 4. All right, so that will be our answer there, and we're done. So we first use long division, and then we had to decompose. All right, so that is it for part C. So for part D, you can try it out because that's just the same as B and A. Okay, so that's the same as B and A. Okay, and as well as part E, you can try it out. Okay, so part E is the same as part C. You first have to divide using long division, and then what you get, you decompose. Okay, so now I'll go to part F, which has a repeating factor there. So that is 8x plus 3 divided by x minus 2 and then squared. Okay, so we said, how are we going to be handling a repeating factor? We're going to say this will be equals to a divided by x minus 2 to the power 1, and then plus b divided by x minus 2 to the power 2. And then we're going to multiply throughout by x minus 2 squared. So simply the denominator on the left. So if I multiply this with this, I just have 8x plus 3 is equals to. If I multiply this with this, one of these is going to cancel out. So I'll have a and then x minus 2. Plus, if I multiply this with this, it's going to cancel out. This thing and this will cancel out. So I'm just going to remain with what? Just going to remain with b. Okay, I'm just going to remain with b. So here we can't use elimination. We just have to use expansion. So this will be 8x plus 3 is equals to, expand here, I have ax minus 2a plus b. And then we equate. So whatever has x here, it's the same as whatever has x there. So ax is equals to 8x. So meaning a is equals to 8. And then this 3 will be equals to the constants there. So minus 2a plus b. All right, so b will simply be equals to 3 plus 2a. So I've just gotten this guy and take it to the other side. So B will just be equals to 3 plus 2, and then the A is 8. So B is equals to 3 plus 16. So B will just be equals to what? To 19. All right, so it means my final answer will just be, so my A, we found it was, okay, my A, we found it was 8, and then my B, we found it was 19. That's all. We're done. All right, so what about part G, where we have a repeating and a linear? Okay, we have a repeating and a linear. So that will be 6x squared plus 5x plus 1 divided by x plus 3 squared, and then x minus 1. So again, you check the highest power. So the highest power there is 2, but the highest power in the denominator is going to be 3 because from this expression, I'm going to get my highest power to be x squared. Then this x squared multiplied by this, okay, I get x power 3. So the highest power in the denominator is greater than the highest power in the numerator. So we're good to go to decompose. So this will be equals to, so for the repeated factor there, that is a divided by x plus 3 plus b divided by x plus 3 to the power 2. So here I should have said to the power 1, and then plus c divided by x minus 1. Okay, then we multiply here throughout by this denominator. So if I multiply this by this denominator, I just get 6x squared plus 5x plus 1 is equals to. If I multiply this whole thing here with this, okay, one of the x plus 3 is going to disappear. So I'm just going to have x and then x plus 3 and then x minus 1. All right, and then if I multiply this whole thing with x, b over x plus 3 squared, the x plus 3 is going to cancel. So I remain with b and then x minus 1. Plus, if I multiply this whole thing with the c over x minus 1, the x minus 1 is going to cancel. So I remain c multiplied by x plus 3 to the power 2. Okay, so that is what I have there. Okay, that is what I have there. So now I just have to find the values of a, the values of b, and the values of what? C. So how am I going to find those values? Okay, how am I going to find those values? So we can use substitution or we can use elimination. So in this case, I'll just choose elimination, okay, or expansion in short. So this will be 6x squared plus 5x plus 1 is equals to, I expand here. So I start from here. So this will be a, then x multiplied by x squared plus x multiplied by minus 1. Okay, I get minus x. Then 3 multiplied by x, I get plus 3x. 3 multiplied by minus 1, I get minus 3. Okay. And then this one here will just be a x squared plus 2x minus 3. So that's what I'll write here. Okay, next I have plus b and then x minus 1. Then plus c. Then this guy here expands. So that will be x squared plus 3x plus another 3x and then plus 9. Okay, this one will give us 6x. So now let's expand with the numbers that are outside. So this will be 6x squared plus 5x plus 1 is equals to a multiplied by this a x squared plus 2a x minus 3a, then plus bx minus b plus cx squared plus c multiplied by the addition of this. So that would be 6cx plus 9c. So I'm going to group whatever has the square together, whatever has x together, and whatever does not have any x together as well. So this will be 6x squared plus 5x plus 1 is equals to, this one and this one have x squared. So that will be a plus c and then x squared. Okay, and then what do we have? The ones with the x is this one, and that one. Okay, so they all have a plus, so that is plus 2a plus b plus 6c and then x. Okay, and then from there now, I combine whatever does not have x, minus 3a minus b plus 9c. So I'll start with the plus 9c, then minus 3a, then minus b. Okay, so once we have this now, we can equate with what we have on the what? on the left-hand side. So you see that the one that has the square, okay, its coefficient here is what? Is 6, this one here. So this 6 is going to be equals to A plus C is equals to 6. And then this 5 is going to be equals to 2A plus B plus 6C. And then this one is going to be equals to the constant. So that is 1 is equals to 9C minus 3A minus B. Okay, so that is what we have now to find the values of A, B, and C. So from this guy here, we can make A the subject. We say A is equals to 6 minus C. And then we substitute it into here and there. So this will be 5 is equals to 2. The A is 6 minus C plus B plus 6C. Okay, the other one is 1 is equals to 9C minus 3, 6 minus C minus B. So this will be 5 is equals to 12 minus this guy here, going to be 2C, okay, plus B plus 6C. 1 is equals to 9C minus, this will be 18 plus 3C minus B. So this here will be 5 is equals to 12. Okay, 12, and then plus B plus 4C when I combine this and this. So I can take the 12 to the other side. So that would be 5 minus 12. So that would be minus 7 is equals to B plus 4C. Simply meaning that B is equals to minus 7 minus 4C. Okay, what about here? To be 1 is equals to 9C. In fact, I combine the C's. I'm going to have 9C plus 3C. That will be 12C. Then minus 18 minus B. So, okay, so this will be, I bring the constant to the other side. That will be 1. And then this negative 18 comes the other side. So that will be plus 18. So that will be 19 is equals to 12C minus B. Okay, I have this equation. So now we've said here that B is equals to this. So this will be 19 is equals to 12C minus, this B is minus 7 minus 4C. So I have 19 is equals to 12C, okay, plus 7 plus 4C. So let's add the 12C plus the 4C. I get 19C, 19 is equals to 16C plus 7, right? Okay, so meaning that I have 16C is equals to 16C is equals to what now? Is equals to okay, is equals to 19 minus 7. So 16C to okay, so this would be equals to okay, so this would be equals to 12. So divide by 16, divide by 16, 4 into 12, that would be 3. 4 into 16, that would be 4. Okay, so that is what I have as my value of C. Then when I have my value of C, I can easily find B and A. Okay, so A will be equals to 6 minus C, which is 3 over 4. So this will be 4. Okay, over 1. 1 into 4, 4. So it will be 24 minus 3. So that will be 21 over 4. Then my B will be equals to minus 7 minus 4, and then 3 over 4. So that would be minus 7 minus 3. That would be minus 10. So my A is 21 over 4. My B is minus 10. My C is 3 over 4. All right, so now that we find the values of A, the values of B, and the values of C, we can simply put them there. Okay, so let's erase this part. Okay, so when we decompose this guy, we can erase this A, erase that B, erase the C. So we can now replace it with the numbers. So A was 21 over 4, B was minus 10, and then C was 3 over 4. So for these denominators, I mean for these ones here, which have a fraction on top, I'm going to multiply this by 4 and also the denominator by 4. This one, I'm going to multiply by 4 and also the denominator by 4. So what I have will just be 21 divided by 4 multiplied by x plus 3. Then this is minus minus 10 multiplied by the positive there. So I get minus 10 divided by x plus 3 and then squared and then plus there. When I multiply by 4, I remain with 3 divided by 4x minus 1. Okay, so those would be my partial fractions for the expressions that we had on, this was what? This was G. All right, let's look at H. So H is this guy. We have 9x minus 4 divided by x minus 5 to the power 3. So this is a repeating factor. So I'm going to say this is the same as a over x minus 5 to the power 1 plus b over x minus 5 to the power 2 plus c divided by x minus 5 to the power 3. So this is what we have here. So now from here, I'm going to multiply throughout by the denominator that I have on my left. So x minus 5 to the power 3, I multiply throughout. Here, I'm going to get 9x minus 4 is equals to, when I multiply this with a over x minus 5, okay, one of the x minus 5 is going to cancel out from this. So I remain with a and then x minus 5 squared, because one of them has cancelled out. If I multiply this with this, okay, 2 of the x minus 5 cancels out, so I remain with x minus 5, and then plus, if I multiply this with this, okay, the x minus 5 to the power 3 cancels out, so I just have a c remaining like that. All right, and then from here, I'm just going to expand here. So this would be 9x minus 4 is equals to, here it will be a, I expand what I have here. So what I have here is the same as x minus 5, and then minus 5, x minus 5. So this would be x squared minus 5x minus 5x plus 25, x squared minus 10x plus 25. So this is what I have there. Okay, and then here it will just be plus b, x minus 5, and then plus c. So we can continue with our expansion. Here I'm going to have 0x squared. You know why I've added this later on. Then plus 7x minus 4 is equals to, here this will be a x squared. Okay, it will be ax squared. And then minus 10a x, then a multiplied by the 25, that will be plus 25a, okay, plus bx minus 5b plus c. All right, so now you can see that I have a term with x squared, okay? I have a term with x and x, so I'm going to group them like that. So it will be 0x squared plus 9x minus 4 is equals to ax squared. And then this one that had x and this one that had x, I'll put them together. So I'll start first by writing the word with a positive. So that will be plus b, and then this one is minus 10a. And then both of these have an x that are factorized like that. And then those that do not have any x, it's 25a minus 5b and then plus c. And then now I'm just going to equate. Okay, I'm just going to equate. So whatever does not have any x will be equated to the minus 4. Whatever have x will be equated to the 9. Whatever has x squared will be equated to the 0. So this simply means that a x squared is equals to 0 x squared. So divide both sides by x squared, I get a is equals to what? To 0. Okay, and then 9 will be equated to this. So that will be 9 is equals to b minus 10a. But now the a we found it is 0. So it means b is simply what? 9. Okay, and then this constant minus 4 is equals to 25a minus 5b and then plus c. But the a is 0, so this part here becomes 0. So this would be minus 4 is equals to minus 5. The b is 9 and then plus c. Okay, so minus 4 is equals to, what is 5 multiplied by 9? So 5 multiplied by 9, that will give you 45. In fact, that should be minus 45 because there's a minus there. And then plus c. Okay, so here I'm going to say the minus 45 goes to the other side, so it becomes positive 45 minus 4 is equals to c. So simply meaning that c is equals to what? To 41. Okay, so we are done. So we found the c. the B, and the A. Okay, so what is my A? I'll put it on top there. What is my B? I'll put it there. What is my C? I'll put it there. Okay, so my A is 0, my B is 9, my C is 41. So this part here becomes all 0. So meaning 9x minus 4 divided by x minus 5. When you decompose it into its partial fractions, it's just going to be 9 over x minus 5 squared plus 41 divided by x minus 5 and then square to the power 3, sorry. All right, so that will be our final answer there. Okay, we'll move on to I. So we look at part I. Part I has a repeating factor and a linear factor, same as part J. So I'm just going to solve part I. Part J, I'll leave it for you guys. So part I, it's 2x squared plus 7x plus 5. This is being divided by x plus 2 squared and then x minus 4. So this will be equals to, for this one which is repeating, it will be A over x plus 2 to the power 1 plus B over x plus 2 to the power 2, okay? And then plus C divided by x minus 4. So this is what we have. So now we multiply this throughout by this denominator here. So if I multiply this whole thing throughout by this denominator, here, this denominator will cancel out. So let me show the guy. So we are multiplying by x plus 2 squared and then x minus 4. So if I multiply throughout, I'm going to get 2x squared plus 7x and then plus 5 is equals to, if I multiply this guy with this, okay, one of the x plus 2 cancels out. So I have A and then x plus 2 and then x minus 4. Okay, and then plus, if I multiply this with this, the x plus 2 squared cancels out. So I have B and then x minus 4. And then plus, if I multiply this with this, the x minus 4 cancels out. So I remain with C and then x plus 2 squared. Okay, so for us to find the value of A, B, and C, we need to expand the right-hand side. So this will be 2x squared plus 7x plus 5 is equals to, let's expand this guy. So that will be x multiplied by x minus 4. Okay, and then plus 2 multiplied by x minus 4. So this gives me x squared minus 4x plus 2x minus 8. So this will be x squared. Okay, if I combine these, that will just give me minus 2x minus 8. So that will be A, x squared minus 2x minus 8 plus B, x minus 4, and then plus C. Let's expand this. So this is x plus 2 multiplied by x plus 2. So that will be x plus 2, and then plus 2, x plus 2. So x multiplied by x squared multiplied by 2 plus 2x, 2x multiplied by this plus 2x, 2 multiplied by that plus 4. So this gives me x squared, okay, plus 4x plus 4. So I'll have x squared plus 4x plus 4. All right, so that is what I have there. Then from there, I can expand with the letters that I have outside. So this is ax squared minus 2ax minus 8a plus bx minus 4b plus, here this will be cx squared plus 4cx plus 4c. Okay, and then here I have 2x squared plus 7x plus 5. All right, so that is what I have there. So now on my right-hand side, I'm going to group them. Those that have x squared, I'll put them together. So that will be a plus c, and then I factorize the x squared. Those that have x, it will be this guy, and that guy, and this guy. Okay, so I'll start with the positive one. So it will be plus b minus 2a, and then plus 4c. And then I have factorized the x. And then those without any x, it is this, this, and that. So I'll start again with the positive one, 4c. Okay, and then I write minus 4b, and then minus 8a. Okay, so this is equals to 2x squared plus 7x plus 5. So meaning that these two here and this guy here are the same because they have the variable x squared. So that would mean that a plus c is equals to 2. And then this one here is 7x. It will be equals to this guy with the x. So that would be b minus 2a plus 4c is actually equals to 7. Then this one here, the 5, will be equals to this constant. So that is 4c minus 4b minus 8a is equals to 5. Okay, so that is what I have there. So from there now, we are going to, here we can make a the subject. So it will be a is equals to 2 minus c. Then we substitute it there. So that will be b minus 2. The a is 2 minus c, and then plus 4c is equals to 7. So this will be b minus 4 minus, in fact, that will be plus, because negative and negative. So that will be plus 2c plus 4c is equals to 7. Okay, let's leave it there. We come to this one, that will be 4c minus 4b minus 8, and then the a is 2 minus c, which we made there. So that will be equals to 5. So we have 4c minus 4b, and then 8 multiplied by 2, that will be minus 16, minus 8 multiplied by minus c, that will be positive 8c is equals to 5. Okay, so that is what we have there. Okay, so now from these other two equations that we got, this one here is b minus 4. Then I can combine 2c and 4c. So that would be plus 6c is equals to 7. Okay, so simply meaning that b is going to be equals to 7 plus 4 minus 6c. So b is equals to 7 plus 4, which is 11 minus 6c. And then from here, we have 4c, okay, plus 8c. So that should be 12c, okay, minus 4b is equals to 5. And then I take this minus 16 to the other side. So that is plus 16. Okay, so that is what I have. So, yeah. So I'm going to replace where there's b, I'm going to put this guy. So that will be 12c minus 4. Where there's b there, that is 11 minus 6c is equals to 5 plus 16. So this will be 12c, 4 multiplied by 11, 44, minus 4 multiplied by minus 6c, that will be plus 24c is equals to 5 plus 16, that is 21. Okay, so we see that we have c and c there. So we are going to add the 12c plus the 24c. That will give me 36c is equals to 21. This minus 44 goes to the other side, plus 44. Okay, so simply meaning that what will be my c? So it will be c is equals to, what is 21 plus 44? Okay, so 21 plus 44 gives me 65 over 36. Okay, so this is the value of c that we found. So we can use it to find the value of b and a, since we have the c. So we're going to use those two equations that we had found earlier. So this will be b is equals to minus, 11 minus 6, and then 65 over 36. So this will be 11 minus 6, and then 65 divided by, I'm supposed to cancel out some things here. So I'm supposed to say 6 there, 1, 6 there, 6. So that gives me 65 over 6 divided by 1. So this will just be equals to 6, and then 1 into 6, that is 6, multiplied by 11, 66 minus 65. So b is going to be 1 over 6. Okay, so b is 1 over 6. Let's find a. So a is given by this. So that is a is equals to 2 minus c. So the common denominator here is 36. So this will be over 1. 1 into 36. Okay, that is 36. And then 36 multiplied by the 2, which is above there, that will be 72, minus 36 into 36, 1 multiplied by that, 65. So this is going to be equals to 72 minus 65. So that gives me 7 over 36. So my A is equals to 7 over 36. Okay, so we are done. We can now put these back into the formula there. So I'll erase these guys. Then I add the numbers there. So this one here, the A is 7 over 36. The B is 1 over 6. And then the C is 65 over 36. Okay, so we can't really leave the fractions on top. We said we can simplify it by multiplying by the denominator there. So I multiply by 36, even here I multiply by 36. Multiply by 6, even here I multiply by 6. Multiply by 36, even here I multiply by 36. So our final answer will be that 2x squared plus 7x plus 5 divided by x plus 2, then squared, and then x minus 4. This would just be 7 over 36 x plus 2 plus 1 over 6 x plus 2 squared plus 65 over 36 x minus 4. Okay, so this is the final answer here, and we are done with this video. So I gave you some questions to do, so make sure you do them. Okay, I've deliberately left them out so that you get to practice. So this J here, that is your question. You need to do it. Okay, you need to do that. Which one? Okay, this one, the E, I left it out, I didn't solve it. You need to do it. Okay, and the D, I left it out as well. You need to solve it. Okay, so solve D, solve E, and solve what? J. Okay, so after you solve, you can send your answers to my number 0779 96 40 and then 10. Okay, so that is Tutor Poul Solutions. You're going to find me there. All right, so thank you so much for watching this video. Until next time, I was there for you.